comments?
Okay, but there also is success. My nephew was 2 when he was diagnosed with aplastic anemia, which is not as aggressive as leukemia. I'm not a doctor, but that's my understanding from what we learned at the time. And his brother was a bone marrow match, and so Max gave Simon bone marrow transplant, and Simon is a healthy, happy 13-year-old teenager today with no health issues, no negative side effects. So there are good stories too.
Yeah, and let's be positive now, because we've been negative about this is all doom and gloom. It's not, because this is a genuinely exciting area. It's one of the most exciting areas of medicine there is, I think, in biomedicine right now.
Plus, as far as stem cell goes, it's been around the longest, so they've had a lot of time to perfect it and test it.
So I meant the field is broadly is very exciting, and that's also really important to point. When we're talking about these cancer therapies, this has been around for decades, right? This kind of therapy has been around for decades. But if I was going to put you all on the spot, and that's what I'm going to do, where do you think the most exciting areas of stem cell research are right now? And let's keep the hype in check. and what are you really excited about? I hate this phrase, I'm going to use it, the low-hanging fruit. What do you think? What do you think's on the horizon? And then how would you explain that to patients in a way, to the public in a way that keeps expectations in check?
So I'll jump in. So I'm going to answer that by giving 2 examples. For the low-hanging fruit, which means what therapy is going to be there next, I think co-therapies, things like mesenchymal stem cells that don't really engraft, but they basically supercharge the body's natural wound healing process. They're very safe. There's a lot of work. I think they hold a lot of promise for helping the body in healing itself for things like skin wounds, for example. So things that are not that sexy or exciting, but there's 300 million people in North America who suffer from type 2 diabetes where this is an issue. For me, as a scientist, some of the exciting stuff that we're working on, that Teresa, who's my grad student, is actually working on, is our long-term goal is to actually build a kidney. We're using induced pluripotent stem cells. We're decellularizing organs and repopulating them with stem cells and pluripotent cells. And that's probably 20 years away. Teresa's children will have to come into the lab to continue the research, but that's exciting because we can now start to think about making whole organs. But removing all that hype, that's a long time away. It's sort of our Star Trek studies.
My students presented that study in my class. You'll be happy to hear. What do you think?
Well, it's hard for me to comment on low-hanging fruit for the entire stem cell field. I'm a diabetologist, and frankly, that's all I think about is diabetes. What I can say from a diabetes perspective is that I think that there's tremendous potential in the type of work you would have heard about this morning from Derek Vanderkooy and forgot her last name, Nicastro. Angelina Nicastro? Christina Nicastro. Because the idea would be that even though I suspect a lot of what the focus today has been about type 1 diabetes, keep in mind at the end of the day, for all of the diabetes syndromes, the fundamental problem at the end of the day is an inability of the beta cells to make enough insulin for the body's needs. And so the understanding of the biology that would be coming from this type of work involving stem cells and the type of work that you would have heard about this morning will, I anticipate, have so many important downstream benefits in terms of not necessarily the therapy that we may be envisioning right now, but what we learn about the biology and how that may translate into new therapies, not just for type 1 diabetes, but also type 2 diabetes. So from a diabetes perspective, that would be what I see as tremendous promise in this regard.
And it's funny because I do think about, and again, I'm not a doctor, I'm a medical doctor. I think that I always think of diabetes also because it's the constellation of cells involved are make it a promising area. It's not as complex as growing an entire kidney. You could do you agree with that? That it does, and there may be different ways that you can use the cells that are unusual. Like you've heard about the patches and things like that. Any comments on that? Yeah.
I would actually, so I also study diabetes, and I think from even the paper I mentioned, there is a lot to learn from just the stem cell studies because to create the ones that they created, they used, I can't remember the number, around 150 different factors that they put in a dish and see how the cells react. So throughout that process, we learned a lot about the biology of the beta cells and other cells involved in diabetes physiology. And so, I mean, I've been more than any other area in stem cell research aware of what's going on with developing new beta cells, or developing beta cells out of inducible pluripotent stem cells. And I do think there's a lot that can be learned from that. And because it's like the transplantation that currently exists, the Edmonton protocol, is relatively simple. And if research can eventually lead to the creation of functional stem cells that also remain functional and become vascularized in the patient, it would, I think, be relatively simple treatment. So I think partly for that reason, that is an up-and-coming thing. I mean, I said people get excited and expect a cure in 3 months. That's not quite the case, but I still think that is sort of a hot area.
Not being in a specific field of stem cell research, I read so many articles, and I don't have a science background, so it's really tough for me to say, you know, what's the closest. And I would be remiss as a communications person not to promote something that we're doing at CCRM, which is a company that we are spinning off, and that is to scale up hematopoietic blood, which are blood stem cells, in larger amounts. I was talking about that earlier, why there's a big need for that. And we have a company called XCellThera, EXCELLTHERA, and it's the work of Peter Zanstra at University of Toronto and Guy Savageau at the University of Montreal. It takes molecule, and it takes engineering process that Peter Zanstra developed, and it will mean that people who need stem cell transplants of the blood-forming type will be able to get them from people who aren't a direct match of theirs, which is an issue. Anyway, lots of good things about it. It's something that hopefully you'll be hearing more of in the future. And so to us, that's something that's happening right now because we've now created this company to make this a reality.